Our next presentation is from Emile from RIPE, which is going to be really interesting. Presentation around does the internet route around damage. Emile.
Yes, hello. I hope you.
Hello, welcome.
Yeah, hi. hope you can hear me.
Yeah, we can.
Apparently you can. So hi from Amsterdam, and while I'm starting sharing my screen, I hope this is visible.
We can see. Yeah, yeah, that's perfect.
Okay, does the internet router on damage? So this is a presentation about something you heard about earlier already, and talked about the this event, the LINX113 outage on the 23rd of March. This is for a researcher like me. I'm at the R&D department at the RIPE NCC. These are always interesting events. Of course, they're not interesting if you're running operational networks, or they might be interesting, but in a different kind of way. So these types of big events, or relatively big because we're talking about a very large exchange, are interesting to study. And actually, almost 3 years ago, DKIX had a similar event, and almost 6 years ago, AMSIX had a similar event. So there's a weird coincidental periodicity in this thing. So I hope that that won't continue. So the event itself, we heard all the details about it earlier, but then what I would like to know is how does the internet cope with things like this? So does it route around damage, and how does it actually do this? So and for that, we run a really nice project that can both be used for operational as well as research questions like this, which is called RIPE Atlas. And of course, we have a lot of trace routes running through LINX all the time. So as with previous occasions of outages like this, the analysis that I did was actually figuring out how many paths we see in traceroute stably run through LINX1 in this case, just by seeing its an IP address in the peering LAN, in the LON1 peering LAN, and how many of these are actually stable. So what I did was I found 26,000 source destination pairs in IPv4 and roughly half of that in IPv6 that on the day before the event ran stably through LINX1, and the destination always responded, which means there's end-to-end connectivity. And with that, I just tracked these for the 23rd of March when the event happened. And as you can see in the picture on the left here, it's interesting to see that the dip in LON1 traffic was not the traffic increase in LON2 traffic. So where did it actually go? That's another question that I would love to shed some light on. So as for the first question, does the internet route around damage? If you do the analysis that I just described, you see that as far as we can see with RIPE Atlas, it mostly does. As you can see here in the blue, the darker blue is when everything was okay, and you see the first part of the first graph here shows the 22nd of March, which is super stable blue. So that's what we selected this path for. But you see on the second part of the graph, you actually see the outage as it was described before. So you see a little bit of light blue coming up there, which means the endpoints still responded. So there was end-to-end connectivity, but we didn't see LON1 in the path anymore, meaning this traffic was rerouted. So everything is okay. It's just didn't use LON1 anymore. And actually, then you see the major outage at around 15:30. And then you actually see a shift that a lot of traffic stayed or a lot of paths stayed in this mode, like being rerouted. And yes, of course, we cannot see if that was people who just kept their sessions down in anticipation of what would happen, or if this was just a BGP decision process that because you maybe established a new session, then an older session with the same BGP properties higher up in the BGP decision process was selected because of this, because of the brief outage of that peering session. We also see a little bit of red here, meaning that the end-to-end connectivity was not there anymore as far as we could see in RIPE Atlas, but we also didn't see LON1. That could be explained, the not seeing LON1, that in a trace route, you always see the far end of far end IP. So when it already traversed an IXP, so it's not unreasonable that that part of the graph is there. There was also like an orange, which you there's just a little bit, but you cannot see it on the graph anymore, which is a LON1 was seen, but the end-to-end connectivity wasn't there. And also interesting to see here, I think, is that IPv4 and IPv6 were quite similar. So this was, does it route around damage? I would say it mostly does. Oops, and now I'm trying to, oh, there we go. So the next question is, how does it route around damage? And for this, we use using the same stable path from before. I just looked at what IXP peering lens did I see. I just took all the IXP peering lens out of PeeringDB, and then just did like 15-minute bins of which IXPs do we actually see. And remember, these were paths that were pre-selected for being very stably across the LINX113. So what you actually see here is the majority of, we see the drop again, of course, at 15:13. And at that point, the majority of what we see is paths that don't have an IXP in there anymore. So I didn't look into that in more detail, but I would guess that's mostly people using transit instead of a session over an IXP. The second most what we see, and that's well, it's roughly 2,000 to 3,000 paths, whereas we have a total of 26,000 paths that we look at, is AMSIX and DKIX. So it's moving to other very large IXPs, but of course at a latency penalty of well, 5 to 10 milliseconds, and they also go off they will cross country borders in this case, so they will go out of the UK before moving back. And we saw only a small fraction of LINX LON2 and LONAP, which I find is interesting. And in IPv6, again, we mostly see the same. So this answers or sheds a little bit of light on how these paths were actually rerouted. So it's mostly probably transit that they were rerouted to. So that's the analysis that I would like to share with you. I hope it provided some insights. There's a RIPE Labs article there where you can read all of this back again. So I hope that gave some insight and maybe some discussion. So I'd love to hear if people have questions.